In this lesson, we're going to be going over the sine law. So just a little reminder is when you're working with a triangle, we always use capital letters to represent the angles. So here we've got angle A, angle B, and angle C. And we use lowercase letters to represent the sides. So side A, side B, and side C. And opposing sides of angles always correspond. So they will have a matching letter. So capital A for angle A corresponds with or goes with side A, lowercase a. Same for B and C. So we have pairs of angles and sides like that. Also remember, really important, that within a triangle, the three angles will always add up to 180 degrees. So in this triangle, we have an angle of 47, 59, and 74, which is a total of 180. So using that rule there, we look at this first example. It asks you to determine the measure of this unknown angle. Basically here, remember this little square means that this is 90 degrees. This is 59 degrees. So in order to find the missing angle, we take the total, so 180, and we subtract the two angles we know. So minus 90 minus 59. When we do that, we get 31 degrees. So this angle here is 31 degrees. Now, in previous grades, we learned about SOHCAHTOA, and we use SOHCAHTOA, or the primary trig ratios, to solve for right angle triangles. So you might be familiar when you have a right angle triangle, we always have an angle, and then we'll have sides, so we would have an opposite side, a hypotenuse, and an adjacent, and then we use SOHCAHTOA, sine, cosine, tan, to solve for unknown sides of angles. But what we're going to do now is we're going to figure out, well, how can we solve triangles that might not have a 90-degree angle? So if they don't have a 90-degree angle, we can use either sine law or cosine law. So in this lesson, we're going to focus on the sine law. And the sine law is basically made up of a series of ratios that are all equal. The sine of angle A divided by side A will be equal to sine of angle B divided by side B, and is also equal to sine of angle C divided by side C. Now it's important to note that when we use the sine law, we always only use two of these ratios at a time. We don't use all three. But it's really important to make sure that you keep yourself organized, that the angles go with sine. Remember, sine is a function that needs an angle with it. And the sides kind of work on their own. So we need those pairs of sides and angles. So the easiest way to learn this formula is to just try an example. So here we have a triangle where we know two of the angles. We know one of the sides but not the other side. And we're looking for this side C. So you'll see here we have angle C, and it's 92 degrees, so not a right triangle, meaning we can't use SOHCAHTOA. And it goes with this unknown side C. And we have angle B, 21 degrees, that goes with this unknown side, 3.04. So in order to set up my formula, here I'm working with C and B. So I'm going to use sine C over C equals sine B over B. Ultimately, these letters don't really matter as long as you put your pairs of angles and sides into the same ratio. So how I like to set it up is I like to start with the, really doesn't matter, I like to start with the pair that I know. So I've got a pair here where I know the angle and I know the side. So I'm going to start with sine of 21 over 3.04. And then I'll set that equal to the pairing there's an unknown. So here I've got sine of 92. The angle, notice that on the top here I've got sine 21, sine 92, so I've got the angles on top, and the sides are on the bottom, and C is the unknown. As I mentioned, these can be rearranged in lots of different ways. Some people like to start with the unknown and then write it that way. It really doesn't matter as long as your angles are beside your angles and your sides are beside your sides, and that they correspond, so corresponding angle and side are paired up properly in the ratio. Now in this scenario, we've got two ratios and one unknown, so we can use cross multiplication and division to solve for our unknown. So sine of 92, you want to make sure that your calculator, make a note of this here, is in degrees. So on your calculator screen, you should see either a capital D somewhere, that's what my calculator shows, or it should say DEG, something like that on your calculator. Some of them say DRG. Make sure that it says that somewhere. If you're not trying to change it, just check with me. So we're going to do sine of 92 times 3.04. I should also mention that some calculators will cause you to put brackets. So if it gives you an open bracket, so when you click sine, if it gives you an open bracket, make sure you put in 92 and then close the bracket. Mine doesn't use brackets, so I'm just going to do sine 92 times 3.04 divided by sine 111. It gives me side C equals 8.5. I'm going to round to 1 decimal place. And this diagram is in centimeters. 8.5 centimeters. Now, I can also use the sine law to solve for unknown angles. There's just one extra step. So again, I'm looking for this missing angle. The first thing you need to do is determine if you have a pair of an angle on the side where you know both, and then determine the corresponding side or angle to your missing piece. So here this missing piece is angle C, but I know its side length. So this is C, and this is angle B. So I know its angle, and I know its side length. So again, I like to start with the pair that I know. So here I know sine 45 and its side. So sine 45 and its side is 7.91. And over here, the angle is my unknown. So sine C is the unknown, and 11 is the side that goes with it. So again, now my unknown is up here. Again, I can use cross multiply and divide. So 11 times sine 45 divided by 7.91, which is 0.983. And that's equal to sine of C. Now we don't want sine of C though, we just want angle C. So in order to get just angle C, I need to get rid of this sine. And if you recall from when you were learning SOHCAHTOA, how we do that is we use the inverse. So sine inverse of 0.983 will give us just angle C. That gets rid of this sine there. To get sine inverse on your calculator, most often you're going to hit shift or second function, and then the sine button, and then put in your decimal, 0.983, and we get an angle of 79.4 degrees for angle C. And one more example to show you. Here, we're looking for the missing side, so this is missing side B. So again, I start by figuring out my pairs of angles and sides. So I can see here that Side B, this triangle is a little bit thin. I find when the triangles are thin, sometimes kind of skews the pairs. But here we have side B and angle B, so 59 degrees on our unknown side. And then we have this angle C, but we don't know its side. And we have this side, but we don't know its angle. Now when you run into that scenario, what you can remember is that within a triangle, the angles should equal 180. So if you know two of them, you can solve for the other one. Because as it stands, we don't have a pair of an angle and the side that's complete. And remember, we need at least one pair where we know the angle and the side. Without that, we have nothing to start from. So I'm going to solve for angle A by subtracting these two other angles. And it leaves me with 24 degrees. So this is 24 degrees. And so now I have an angle and this side that's 2.92. And that's what I'm going to start with. So sine 24, 2.92 is the pair that I know. And then I'm looking for side B. So I need to use this angle of 59. So sine 59 over my unknown, which is B. And then I cross multiply and divide. I get sine 59 times 2.92 divided by sine 24. So B is equal to 6.15 centimeters. So that is how we use the sine law to solve for unknown sides or angles in a non-right triangle.